In the diagram, chord BD is creating an angle alpha and beta at the edge of the circle CBDE or BCDE. Now observe the values of alpha and beta. As at now, they are all 58 degrees. Now observe as I change the length of the chord, how the angles also change. As at now, they are all 36 degrees. They are all 18 degrees now. If I move it around, they are still of the same value. Now let me move beta around whilst alpha is at the same place. No matter how I move it, you realize that the values are equal. Their values are equal. I can move it as far as very near to the D. The farther it is still in the same segment with alpha, the value is still the same. So most of the times in the exams, students know that when they are in the same segment, their values are equal. But as soon as they change the orientation of the angles, which is not showing clearly, they become confused and they don't know the relationship to establish for them to use and work. From this, we can observe that whilst alpha and beta are in the same segment, their values are the same. Now if I move it to this segment, you realize that alpha is not equal to beta again, because now they are in different segments. The segment is created by BD. So an angle is either created by a chord or an arc. So this angle is created by chord BD and arc BD. So you have to take note that whilst they are in the same segment, their values are equal. Also, this is because chord BD is equal in length. It can be seen that this chord BD, it is not only one line. There are two lines that are there, that of BCD and BED. Now these angles are the same, or they are equal, because the length of this chord are equal. So the chord of triangle, or the base of triangle BED and triangle BCD, that are creating these angles, because they are coinciding and they are equal, they have these angles equal over here. In the same way, if they are not coinciding, the fact that these two chords are equal, the angles that they create over here will also be the same. So right now, the two chords are equal. That is why no matter how I move, or no matter how the size changes, the values of the angles are still the same. Now here is the center of this circle. You might not agree that these two lines are the same, but if I move it so that they become, or they lie on each other, you can see that they are actually equal. So now you can see clearly that the two lines are equal. That is why they are subtending, or they are creating the same angle at the edge of the circle, or at the circumference of the circle. Now this is a special case. You realize that the chord is passing through the center now, and this kind of chord is a special chord known as the diameter. So the diameter will also create angles that are equal in the same segment, but that angle is special. They are the 90 degrees angle. So if you have three or more angles created by a diameter, the values are 90 degrees each. We shall look at how we use this to solve questions in the next video. But for now, see whether you can answer the following question. What is the relation between alpha and beta whilst they are in the same segment? The answer is that whilst they are in the same segment, their values are equal. Then also, what is the relation between alpha and beta whilst they are in opposite segments? So whilst they are in opposite segments, if I move the E to this segment, you realize that their sum will give us 180. So as at now, alpha plus beta will be equal to 180. Doesn't matter how I change the size, no matter how I change it, you realize that their values will add up to 180 degrees. This is because they are in opposite segments. We'll come to see later another theorem which is also very similar to this, called cyclic quadrilateral, in a later lesson. But for now, note that so long as we have a chord that has created two angles, if the two angles are in the same segment, then they will have the same value, 93, 93 as at now. But if they are in different segments, that is, they are in opposite segments created by the same chord, then they will add up to 180 degrees. Hence, the answer is that whilst alpha and beta are in opposite segments, they will add up to 180 degrees.